For this system of equations, for what value of a is there a unique solution, no solution, or infinitely many solutions? Now, looking at the equations, the a is here multiplying the z, so when we eliminate it's best to use one of the other letters so that we don't get too algebraic. So let's go 1, 2, 3. If I do equation 1 add equation 2, that can get rid of y. So I'll get 3x, the y's disappear, I get 2z's equals 3. And if I do equation 2 add equation 3, that will also get rid of y. So if we add here, we just get a single x, the y's disappear, and then I get z plus az, which is a plus 1 z's, and that's going to be equal, we added the equations, to 11. Let's call this one 4, and I'm going to multiply this one by 3. So that gives me 3x plus 3a plus 3z is equal to 33, and I'm going to call that 5. Now, if 3a plus 3 is equal to 2, this one would be 3x plus 2z is equal to 33. And that would be inconsistent with this one where 3x plus 2z is 3. We can't have 3x plus 2z being both 3 and 33. And we couldn't solve that, so we would get no solutions. So that means that 3a would be equal to negative 1, a is equal to negative third. So that's the situation with no solutions, if a is equal to negative a third. If a is not equal to negative a third, then we could go ahead and solve. There'd be no problem here with eliminating x if 3a plus 3 is something different to 2. We could just subtract the equations, and then we'd get a certain number of z's is equal to 30. We can then find z, come back here and find x, and then go back to the original equations and find y. So that would give us a unique solution. And for this set of equations, there's no way that we can produce infinitely many solutions. So just to discuss that, with infinitely many solutions, what we would need is where we had these inconsistent equations here, we discussed it, I'll do it in red so we don't get it confused with the working. 3x plus 2z is equal to 3, and where we had this situation where a was negative a third, so we would have had 3x plus 2z is equal to 33. These are inconsistent because we have the same left-hand side, but a different right-hand side. Effectively, they're parallel lines, so they're never going to intersect. To get infinitely many solutions, we'd need to have consistent equations, and that means that if we had the same left-hand side and the same right-hand side, we can't go ahead and solve, but instead of being parallel, they're actually the same line, and that would give us an infinite number of solutions. So we can't produce that from this particular set. Now we want to solve in the situation where a is 3. So 3x plus 2z is equal to 3 was number 4. And if a is equal to 3, that would give us 3x plus 12z equals 33 was number 5. And if we subtract, that gives us 10z equals 30, so z equals 3. So come back to here, and we get 3x plus 6 equals 3, so 3x equals negative 3, so x is negative 1. And then go back to the original equations. Let's use number 1. So sub in 1. And we've got x is -1. We don't know y. We know that z is 3. That's equal to 2. So that gives us y plus 2 equals 2, which is y is 0. So we have x is equal to -1, y is 0, z is 3.